Today we will learn about consistency. Now, consistency of an estimator means that as the sample size n gets large, the estimate gets closer and closer to the true value of the parameter. Okay, so what is consistency of an estimator? Consistency of an estimator is nothing but as n or small n your sample size gets large, the estimate gets closer and closer to the true value of the parameter. Now I know repeating the sentence doesn't make any sense, so we will go into the depth of what this sentence is all about. Now let Tn be a statistic where n is the sample size. Now Tn is said to be a consistent estimate of a parameter theta if for any two possible numbers epsilon and eta, a capital N can be found out such that for n greater than or equal to capital N, we have the equation probability of the absolute value of Tn minus theta less than epsilon is greater than 1 minus eta. Now this is also a bit of confusing towards the end. Now what does this mean? It means that it can be also expressed by saying that if Tn is a consistent estimate of theta, if it tends in probability to theta as n tends to infinity. That is what I have written over here in a mathematical equation. If Tn is a consistent estimate of theta, this term in probability will tend to theta as n tends to infinity. Now again we will go into depth. This means that if Tn is a consistent estimate of theta, the difference between Tn and theta, let's have a look at the formula. The difference between Tn, that is the statistic, and the estimator theta, can be made small, that is epsilon over here, the value this is very much less than epsilon. Epsilon is again a very small quantity, but a positive quantity, can be made small, we please, in almost all samples of size n if the sample size is sufficiently large. That is the probability of getting this, the difference of these two things, that is the statistic and the estimate theta, will be small when n tends to infinity. So the definition of this can also be stated as Tn is a consistent estimate of theta. If you see, usually you get problems like check whether the particular statistic is a consistent estimate of the parameter. That is what you get. So by definition, or if we generalize, Tn is a consistent estimate of theta if probability that the difference between the statistic and the parameter tends to 1 as n tends to infinity, or as n becomes large. It is also noted that the consistency is a large sample property. Usually it comes in the case of large samples, while unbiasedness is defined for all sample sizes. Okay, so unbiasedness we have studied earlier. And one more result, or one more point that I have to stress over here, is that a consistent estimate need not be unbiased for small samples, but it becomes unbiased as n tends to infinity. Now we have to check the sufficient set of condition for the consistency of an estimate. So let's have a look. So let's see what is the condition, or the sufficient condition for the consistency of an estimate. So this is the theorem. If expectation of Tn, if expectation of Tn is equal to theta, or if expectation of Tn tends to theta and variance of Tn tends to 0. See, these are the condition. If expectation of that particular statistic tends to the parameter and the variance of the statistics tends to 0 as your n, that is the sample size, gets large, that is tends to infinity, then we say that Tn is a consistent estimate of theta. Okay, so what are the conditions? The conditions are that if the expectation of the statistic, that is Tn, is equal to theta, or expectation of Tn tends to theta, and the variance of that particular statistics tends to 0 as n tends to infinity, then Tn is said to be a consistent estimate of theta. Now we'll have to prove this, and for the proof we will take the help of Chebyshev's inequality. Okay, so first you consider the Chebyshev's inequality. Okay, so let's have a look. What is the Chebyshev's inequality? Probability of modulus. See, the notations that you might have studied will be a bit different over here, but the whole idea behind this inequality is the same. Probability of modulus Tn minus theta less than epsilon greater than 1 minus variance of Tn divided by epsilon square. Now mark this as equation number A. Now consider this term, that is modulus Tn minus theta. Okay, modulus Tn minus theta, how will you write this as? This is equal to modulus Tn minus theta n minus theta. See, is it fine to write like this? Tn minus theta, I introduced a theta over here, that's all. Okay, I added a theta and I subtracted a theta, and just I rearranged the whole term. Now this is equal to, let's see, now this is something greater than or equal to, I'm going to separate these terms, modulus Tn minus theta minus modulus theta n minus theta. Now I'm going to put this back to equation A and see what I get. Probability of modulus, instead of this I'm going to write this whole term. Okay, so probability of Tn minus theta minus modulus of theta n minus theta less than epsilon greater than 1 minus variance of Tn divided by epsilon square. Okay, now okay, now okay, I'm going to rewrite that again. Probability of modulus Tn minus theta less than, minus modulus theta n minus theta less than epsilon greater than 1 minus variance of Tn divided by epsilon square, which implies probability of modulus Tn minus theta less than, what I'm going to do is I'm going to take this term to the right hand side, that is towards the epsilon. So what will I get? epsilon plus, this negative sign will change into plus, the modulus theta n minus theta. This is a modulus sign, okay. Greater than 1 minus variance of Tn divided by epsilon square. Now we have that expectation of Tn is what? Expectation of Tn, according to our theorem, expectation of Tn is equal to theta, or expectation of Tn tends to theta. Now expectation of Tn is equal to actually theta n. Now this tends to what? Theta. So what about the case over here? Yes, now this is expectation of Tn. What about this? This is something what? Expectation of Tn when tends to theta. So what will this become? Yes, this whole thing will become 0, so which implies probability of modulus Tn minus theta less than epsilon plus 0 greater than 1 minus, we had another condition, variance of Tn tends to 0, and both these conditions are satisfied when n tends to infinity or n is considerably large. So if n tends to infinity or when n is considerably large, this side becomes what? 0 divided by epsilon square, which implies that probability of modulus Tn minus theta less than epsilon greater than 1. Now have you seen this anywhere? Yeah, this is the condition for consistency. So therefore you can say that Tn is a consistent estimator of theta. Okay, so thank you. Now we will move on to some problems.